Okay, so again, we're gonna get through this so I can give you a little bit of time to work on homework, but we are gonna finish P5. Everybody's with me? Everybody's got their calculators? If you don't have your calculators, remember I told you about Calculate 84. You can get that up on your iPad or you can just watch me. That's totally fine. Can you do it on your iPad?
So my iPad's dead.
Why is your iPad dead?
I don't know. I have a charger.
You can use my prepaid calculator.
I have the same one. It's just at my house. That's this one.
Okay. Why isn't that just yours?
I don't know. It's just,
I think pink is such a fun color. Anybody can
no,
like pink.
I like pink. It's just like the rose.
You're wearing a purple shirt.
No, it's TCU. It's for the rocks.
Anyway, I miss Megan. I wish she was here.
Yeah, I know. No, and like,
Too bad. Last year.
well, no, she graduated last year. But
Okay.
got her nursing and all that. She's working at the UK hospital.
Nice.
Nice. Anything else?
All right, Nikki, you with me?
Yeah.
Okay, good. Carson, you with me?
Yeah.
Great. All right, let's go. I'm sure we have other things to talk about. Let's get into this though. Let's graph these and let's figure out where they are. I don't think we've talked about this yet. So do any of you remember where the absolute values are on my calculator? Math, very good. Go ahead and be in your Y1 before you go to math, because if you just do math, it'll put those absolute values wherever your cursor was. So be in Y1 and go to math. And then where do I go from there?
Number.
Good, number. And then it's right there, right? ABS, absolute value. Well, when did you put it on?
Oh, right, or like 5 to 10 minutes.
Okay, great. I thought you put it on last night. I was like, it's.
It was my first time having a calculator. Sorry.
Oh, okay. Ever?
Not a lot of insurance.
Thank God we have brothers and sisters, right? Or else we wouldn't have any calculators.
Or
Or clothes.
That's what we were just talking about.
Is that why your pants are short today?
Nice joke. You guys are making me feel bad. He was like, hey, look at my shorts. Or look at my pants.
You're the one who said they were short. That's why I made fun of you right now. I didn't think that they were short.
I know.
Okay, we're done making fun of you. Rack. Oh, my window's crazy. Is you at least have a normal window? Can you remind me, how do I get back to a normal window? Z6, very good. You guys are so good at that. So I'm gonna go here. There's a lot going on. I'm only gonna find 2 points of intersection. I feel like there should be more, but I see one right about here, and I see one down here. Right about there. I thought there was one over here, but I tried to do it and be very careful with it last class, and it didn't matter. So remind me. Oh, Gus.
Well, what do you put as the y or y equals?
The 2 parts of the equation.
Oh,
Isn't that what those are?
yeah.
I've seen that.
Gina?
So what do we press on a calculator second, trace
Yes.
intersection, and then what do we do? Do we just
Great.
enter?
Let's talk about it. You can't go enter. You gotta do a little bit of thinking about it. So second trace intersect. Mine says left bound. What does yours say? First curve? Okay. I think for the most part, you can just do enter on that one. When you say left bound and right bound, make sure you're on the left side and the right side. But if it says first curve, second curve, it should move the cursor for you. You just have to be close enough to that point of intersection so it knows to go there. You can't be like crazy far away. My point of intersection is negative 2.4. Is everybody else getting that?
Yeah. 4-1.
0.41 is the other one.
Oh.
So that's one of them. I get negative 2.4. The other one's 0.4. So then go ahead. If you got one of those, go find the other one. So I get negative 2.4, and I will end up getting 0.4. The reason I know that is I just did that last class, so I'm going to go back and prove it. Second trace intersect. Oh. Feel bad for anyone watching this on YouTube. We've really had a slow start to this.
Oh, is your on there?
Fast forward. I just am recording it and then I'll post it on YouTube. It depends on how loud you are. They may not hear you.
Oh, okay.
But if you're loud, they will hear you.
That wasn't it. Let's make up a whole story.
And then they're like, oh my God.
We'll cut it out.
We'll cut it.
No problem.
You have a lot of confidence in my editing abilities, because I literally just press play, I press record, it records the whole class, and then I post it on YouTube. So everyone can hear this. Left bound, right bound. Intersection at point 4. I feel like there should be another one, but again, last class I really tried to get close and I couldn't find it. So I think those are the two that are best. Okay, everyone good with that? Can I do the one below it? Can I do the one below it?
Yeah.
Okay, I'm gonna keep just going right through these 4, so you kind of work at your own pace. The first 2, A and C, are both ones that we find the intersection of. So we're gonna press intersect, okay? On letter B and D, we're not gonna do intersect. What am I gonna do for B and D?
We
We don't have to do anything first. I'm gonna go plug it in my calculator. But when I go to my calculator, find the zeros. So since it's equal to 0, I don't have a y1 and a y2 where they're going to cross. I'm just going to find the zeros. Okay. So recognizing that how it's set up means that I'm going to set it up different ways in my calculator. So I'll go do letter C now. X plus 1, 2x minus 3. 2x minus 3. And then if you have your absolute value signs up, just use them. If not, remember, go back math, NUM, and then press enter. Okay, correct. Oh, nice. They only have 1 point of intersection, so that'll be pretty easy to find. Left bound, right bound. I get 4. Okay, that's nice.
So left or right bound, just saying. In between those.
Yep. So it normally asks you for bound, like on your graphing calculator, asks you for bounds for 0. You just need to make sure your cursor's to the left of it and then to the right of it. The way that the program in your calculator works is it figures out when do I go from like positive values to negative values, or vice versa. When do I go from negative to positive? That's how it finds exactly where that 0 is. And so you got to make sure you're on other sides of that axis. All right, I did A and C. Now I'm going to go do B and D. Question for letter B. How many zeros, or what's the most amount of zeros that you would expect for number B? 3. Do you remember why we think that the most amount of zeros could be 3? Cubed, because of that exponent right there, right? That's like a fundamental theorem that we learned about a long time ago. We can have less than that, and in this case we actually will, but I want to make sure at most I want to see if I can see 3, okay? So that's just something I want us to kind of start thinking about. You guys know enough things that you can start making like thoughtful and intentional decisions based on what you know. We can do a little bit of forward thinking instead of backwards thinking. But when I go to graph it, you see my curve is kind of hanging out down here. We're going to do some basic function graphs. That is a cubic graph, that's fine. But because of the way it's centered, I only have that 1 0 right here. So I'm just going to go find that. Even though I could have at most 3, this time I only have 1. All of our calculators on this should be left bound, right bound. So make sure you're on opposite sides of that 0, and I get 0.8. I still haven't got attendance yet. Let me do that before Mr. Freegee calls in. Okay, and then do that last one while I'm doing attendance really quick. As I do this next one, do you guys know how to do the radical on your calculator?
Yeah.
Yeah? Okay.
Second x squared.
Very good. So just make sure you follow every other symbol like you're used to. Second x squared, and then x plus 3. If you have an older calculator, it might give you parentheses there. That's okay. Just kind of keep following along. Put those parentheses in. I'll go press graph. And again, I kind of talked about knowing what functions look like. That's going to be next chapter. That is what a radical looks like, or that's like the basic shape of a radical. And so I just have 1, 0 right here. So I'll go second trace and find that. Hopefully this little section was just practicing putting numbers and putting different symbols in our calculator, finding those zeros and intersections. Hopefully that was easy stuff. 2.8. Okay, everybody still with me? That wasn't too bad, was it? Okay. All right. I'm going to do one little word problem, and then we're going to move on to the last part of this section. There are no word problems on the quiz on Friday. Honestly, I don't know how much of these word problems are even on the test, so I'm not that stressed about it. But I do think number 6 is pretty simple, so we can do that one. Everybody's good? Okay. This says several of the World Cup 94 soccer matches were played at Stanford University Stadium at Melno Park, California. The field is 30 yards longer than it is wide, and the area of the field is 8,800 yards squared. What are the dimensions of the soccer field? Okay, what shape is a soccer field? What shape is any field? Rectangle. It says the field is 30 yards longer than it is wide. How am I going to represent that? X plus 30. That's my length. Oh, I don't know why I wrote 90. And then that's its length. So then what is it width? What's the width of this field? X. Very good. And we know its area is 8,800 feet. And how do I find the area of a rectangle? Length times width. So now I have all my pieces. I have my area. I have my length. I have my width. We're just going to plug and chug. 8,800 equals X plus 30 times X. You could put the X in the front, you put the X in the back, it doesn't matter to me. Just kind of keep everything parentheses. Now, to find the dimensions of the field, we got to solve for X. You can do a bunch of things. You're allowed to distribute, you're allowed to solve algebraically, you're allowed to use the quadratic formula. It doesn't tell me I have to though, and so when in doubt, I'd much rather use the calculator. I've got a y1, I've got a y2. I'm going to go plug those in and I'm going to see where they intersect. I also want to do this because I want you to play around with your windows for a second. So go ahead and enter those in, and then I want you to see if you can figure out what's the best window for this. What's my best window for this situation? Let's go talk about my x's. What should my x min be?
I did, oh, minimal, I just kept it in the max, I did, 100, or, -100. Yeah, I did 100, and then Y max, I did 9,000.
9,000. Good.
I can see everything.
Perfect. The only thing I would say, and your mins are fine there, I may even go just up to 0 because there's no way the field width or area could be negative. So the only thing is I almost always, with any kind of word problem that's in real life, I just put my mins at 0, but -10 won't negatively affect my graph. All right, perfect. Now, if you're like, oh, that's not enough of the graph for me, you can make your y max a tiny bit bigger, 1,100, that's fine. Oh, that's wrong. 11,000, sorry, not 1,100. If you want to see a little bit bigger, that's totally fine. But as Avery said, you could see all that you needed to. All you need to see is that point of intersection. So as long as you can see it, you're good to go. And then because we can see it, we can figure out what it is. Find your point of intersection, left bound, right bound, first curve, second curve. And I get x equals 80. What does that mean?
And it's 10 by 80.
Where'd 110 come from?
80 plus 30.
Oh, okay. You went a little farther than me. 30 is one of my field dimensions, right? That's the width. No, 80. Sorry, I don't know why I keep writing 30. 80. And then x plus 30 is that 110. which is my length. So my field is 80 yards by 110 yards.
Wrong here, I got 100.
I don't know what's wrong. Let's see. No, you got 80.
Oh.
You gotta look at the intersection.
I see.
That's where your cursor is right now.
I can do those too, but I did the same thing.
No, you're still on second term. It's still telling you to do second term.
Oh, like having to.
Something's wrong. I think maybe you're still on the curve and you need to be on the right curve, so go down. Like literally press it down there, that's gonna get you to the right curve. See, now we're on the right, so press it there anywhere. And then now enter again for gas. Now you're. See how it comes to right there, so make sure you get all the way to intersection.
No, man, I don't like
All right, there's another word pun, but we're not gonna worry about that right now. Field is 80 by 110 yards. Right. We're gonna skip number 7 for right now. If I feel like doing it, we'll come back to it next week. If I don't ever do it, do you think it's fair game for a test? No, if I didn't do it, it's not gonna happen. Okay, this next part is really important though, and this is something that will be on your homework. It says find the center and the radius of the circle. This comes with complete the square stuff. So we completed the square the other day because now we're going to do kind of this mega complete the square problem. Now I know we don't love complete the square, but I do think that this feels pretty simple once we break it apart, okay? So can you remind me, what is the equation of a circle? We learned that a couple days ago.
8x minus h.
X minus h.
K minus.
Good, squared plus y minus k squared equals r squared. Very good. So we got to get it in this form, and then I'll easily be able to find my center is my h and my k, and I'll easily be able to find my radius. Okay, so we have to start by getting it in that form, and to get those perfect squares, I have to complete the square. So I'm going to look at this first equation, and I'm going to put the x's next to each other and put the y's next to each other. And then if there's any constants on the left-hand side, I'm going to move it to the right-hand side. Okay, so I see x squared minus 8x. I'm going to put those next to each other. And just like when we complete the square, I'm going to leave a little bit of space because I'm going to have to write another word there, another letter, another number. Y and 10y are going to go together. And I got to leave a space for them as well. And then that 5 is going to stay on that right-hand side, just like we moved all the constants away. But I'm not going to just have one blank over here. I'm going to have 2 blanks because if I had something to complete my x squared, I've got to also add it to the other side. Same thing for my y squared. If I add for the y squared, I got to add it to the other side. Got a lot of space. Okay. Who remembers what I get to do next? Now that kind of organized and set up. Kate. Very good. Very good. 8 divided by 2 squared, b divided by 2 squared. I'll do that up here. Negative 8 divided by 2 squared is going to be negative 4 squared, or 16. So that means I get to add 16 to both sides of my equation. I also have to do that for my y's. What's my b for my y's? 10. 10 divided by 2 squared is 5 squared equals 25. So I'm going to add 25 to both sides. It gets really messy, but then that next step, we're going to have everything cleaned up and then we're basically done. Is everybody cool with what I've done so far? Okay, now is where we have to do our factoring. X plus or minus what squared? When I had x squared minus 8x plus 16, 4 is going to be positive or negative? Negative. Why?
I think it's always
Not because it's always negative.
because the 8 is
The
negative.
8 is negative. Very good. Also, remember that hint I told you the other day? Whatever b divided by 2 is, goes in that parentheses. So it's always just going to be that number. It's negative 4 here. All right, what about my y? It's going to be y plus or minus what squared? 5. Very good. Plus 5 or minus 5? Very good. And then I'm gonna clean up that right-hand side. 5 plus 16 plus 25 is 46. I feel good about that. Say what? We are going to square root it, but let's do the center first because that's going to be really easy to identify. The center just comes from my equation. Remember that we have to switch the sign when we take something out of the parentheses. So if it's -4, it's going to become a +4. And if it's plus a 5, it's going to become a -5. That's going to be my center.
Wait, what?
I have to switch my signs when you take it outside the parentheses. Now I'm going to do my radius, and just like Avery kind of alluded to earlier, we have to do the square root because it's not equal to r, it's equal to r squared. So we have to square root it to get r by itself. And so my radius here is going to be the square root of 46. 46 is divisible by 2, but it's 23, and then I can't break 23 down anymore, so root 46 is as good as it gets. So that's my equation of my circle. My center is at 4, -5. My radius is root 46. Do you think you can try the one next to it? Try it, and then I'll do it along with you if you need to check in with me. Try the one next to it. So the way the equation goes is that the answer is r squared. And so to figure out what just r is, I have to square root that number. So 46 is technically equal to r squared. So I gotta solve for r. Yeah. Let's I've got all my work and my answers. All my work and my answers on the board. Yeah.
What about Rascal? Why did you leave the square root off of the y?
You mean, did I leave
Yeah.
a square off? Oh, I just forgot it.
Oh,
That's my fault. Yep. I forgot that exponent, my fault. How are we feeling? Okay. There's one like this on your homework tonight, so I wanted to make sure that we were good with this. Here.
Why do you flip the sides?
Great question. Remember back in Algebra 1 when we were factoring and we had like x minus 1, x plus 5 equals 0. And then when we solved it, we'd say x minus 1 equals 0, so x equals +1. That's the same concept here. As if I were to set that equals 0 and bring it out, it switches the sign. We've done so many more complex things, so we just start just saying, hey, we remember we just switch it without showing any of that work, but I could set it equal to 0. All right, any other questions? Okay, that's the end of P5. We're gonna get into some P6 today, but your homework on P5 is due tomorrow. Is anything on that homework on the quiz? Not one thing, not one thing. Okay, P6 is some complex numbers.
P3 or what?
P3, P4.
Okay.
So solving equations and inequalities, line stuff. You got to know your line equations. That's probably the hardest part, which I don't think is that hard because you did it back in Algebra 1, but if you don't know them, you got to know them. slope intercept, point slope, define slope as y2 minus y1 over x2 minus x1, those basic ones. Okay, if we look at p6, we got a little bit of a taste of this the other day, but now we're going to dive into it. We're talking about complex numbers today. We're talking about imaginary numbers. And did you do imaginary numbers in Algebra 2? Good, so this should be pretty simple to us. Just a little preview, you can label this complex numbers, that's what p6 is. And I don't care if you write your complex numbers as a plus bi or as bi plus a. I don't care if your I term goes first or if your I term goes last. For some reason, I always put my I term last, but that's not necessarily the most correct thing to do. So if you want to put it first, that is fine. What we're going to do is play around with some simplifying and some basic operations today, and then we'll get into some more other concepts after our quiz tomorrow. Since you've done this, this might be a nice little review. This might be a little easy part of today, just to like plug in and chug in some complex numbers. My first one, Z1, that just means complex number 1. Don't let the Z's confuse you. Is 3 plus 2i. And then my other complex number is 5 minus 5i. So we're just going to do a bunch of operations with them. So we'll start with plus. We're going to do 3 plus 2i plus 5 minus 5i. We're adding those two complex numbers together. What am I allowed to do with those? Combine like terms. The numbers with the i's are like terms. The numbers without the i's are like terms. So 3 plus 5 is 8. 2i minus 5i is negative 3i. Awesome. Similar idea for the next one. Let's jump over to letter B. It says Z1 minus Z2. So we're going to just minus them. Take our two numbers, 3 plus 2i minus, and I am going to put parentheses around my second term just so I don't lose any negatives, 5 minus 5i. Distribute that negative. 3 plus 2i minus 5 plus 5i. And then now, just like we said last time, combine your like terms. Negative 2 plus 7i. Everyone good so far? This is easy, right? Nice little change of pace. Letter C is very similar. We just have to multiply by a factor and then subtract them. So we can set that up just the same way we did everything else. 3 plus 2i. And then 5 minus 5i. You probably can do that on your own. Distribute, combine. Okay, and then the last two are multiply and divide, and they're basically the same skill. Everybody good with the adding, subtracting, multiplying just by a factor? Okay, when we multiply two complex numbers together, we're going to treat it like it's an x. Well, this is what I did first yesterday, and I forgot to do with you guys. That's all right. I'll pause and do it again in a second. Treat it like it's an x, treat it like it's a variable, and we're going to FOIL just like we would in Algebra 1. So I get 15 minus 15i plus 10i minus 10i squared.
-1.
Yes, we're going to take a team timeout and we're going to make a little like kind of chart off to the side because there are 4 basic i's that we should know. I bet you only know I and I squared, but with a little bit of prompting, I bet you can figure out I to the third and I to the fourth. Okay. I is the same thing as what? We've been talking about it. You know, I know you're familiar with it. What is that?
Negative.
Not x. -1 under a radical, right? Square root -1. Wow, that's disgusting. Let me try again. That's not much better, but that's gonna be good. So then, guess what you just say I squared was? It's -1. Good. Because when you square a square root, the square and the square root cancel each other out and we just get -1. Okay. when we do I to the third, that's like I times I squared. And what did you just tell me I squared was? -1. So what's I times -1? Negative I. So I can clean up these exponents by making it something simpler. So you might be like, well, why don't we just leave it I to the third? Because it can be smaller, because it can be simpler. It's -I. And then the last one, before we kind of start the cycle all over again, I to the fourth. Think of that like I squared times I squared. And what's I squared? And
So
next,
it's possible.
good. -1 times -1 is going to be +1. So if we go all the way to I to the fourth, then we're back to the real numbers, back to +1. And the way this works, it's like a cycle. So then when I do I to the fifth, that's like going back to I, just normal I to the first. When I do I to the sixth, that's like going to I squared. I to the seventh is the same thing as I to the third. And then I to the eighth is going to be the same thing as I to the fourth. Good. We'll explore more of that next class. But like I could give you I to like a very big number, like I to the 50th, and you could tell me which of these 4 answers I to the 50th is. We're gonna worry about that later. I'm not really ready to teach that today. We're just gonna keep going with I squared. But I thought I'd introduce this while we talk about what I squared is. So we'll come back to that later. I'm just giving you a little bit of taste. We'll worry about that another time. But we know I squared is the same thing as -1. So as I go to simplify this, I can combine my I. So I get 15 minus 5i. And then this -10i squared becomes -10 times -1 or +10, right? I'm going to write a lot of steps on this one. I'm not going to write this many steps on anything else. And then I can end up combining those two to be 25 minus 5i. The hard part is being able to go from -10i squared and making that +10. So if you can do that in one step and we can go directly down here, awesome. If you need to remind yourself it's times -1 and then add them together, go for it. Maggie.
I factored it out into like 2 parentheses.
You factored.
Like I took out a 5 and then I had 3 minus 5 plus 2i.
So you don't have to like factor anything out. I just want you to combine like terms. Once we get to the very end, if this was equal to something, then we could simplify from there. But I want you to just multiply out, add your like terms together, and not worry about factoring any number. No GCS right now. Now let's jump down to the next one. That one's a division problem. However, I think as you maybe remember, it's very similar to what we were just doing. 3 plus 2i divided by 5 minus 5i. Just like we can't have a radical, a square root in the denominator, we can't have an I in the denominator. Do you remember how we get rid of that I? Multiply by. I gotta make it negative, so what am I gonna multiply by? 5 plus 5i. We only change that middle sign. Do you remember? Ooh, that was a hard word. Do you remember what we call that? There's a name for how this and this are related to each other. Not reciprocal. It's called the conjugate. Is that something you remember hearing last year? Okay, well, I'll teach it to you. Conjugate. Conjugate. And I think of conjugate a lot like Spanish. You're conjugating verbs. We're just making a new, like we're changing it a slight bit. So we're multiplying by the conjugate. And whatever you do in the denominator, you also have to do in the numerator. So I also have to multiply the top by 5 plus 5i. Okay. Now we just have this giant multiplication problem. We got to multiply the ones on top. We got to multiply the ones on bottom and simplify. I like to kind of worry about just one over the other to begin with. So I'll do my work out. I'll be quiet though if you think that you can just kind of swing through it. But make sure that we're foiling all the way out, both on top and on bottom. And I'll put my work up, but I'll be quiet for a minute. I put it down to here. Do you guys get here? Should you go further? What else can I do to this?
Factor out 5.
I can take out a 5. Kind of like that triangle simplifying. I don't know if it was last class or you guys that have been worried about the triangle simplifying. But if I have something both the same on top and bottom, I'm going to simplify that out. So that becomes 1 plus 5i over 10. You guys are doing great. Feeling okay? No? What's wrong? Oh. Okay, questions? No? Okay. We're gonna do a little bit more. We're gonna get, I'm trying to get through letter number 3, so we're gonna do a little bit more on those ones. Number 3 is mostly gonna be you kind of work and then you check in with your answers from me. But we can do number 2 very quickly. It says simplify. You guys know how to do square roots, and I know square root of a negative is I, right? So what's square root of negative 16 the same thing as? 4i. What about the square root of negative 25? 5i. And let's multiply them together. 4 times 5 is 20. I times I is I squared. Now, if you're faster than me, you maybe were like, okay, I know it's going to be 20i squared. I know it'll be negative. You can go quicker just down to negative 20 if that works for you. But I, for some reason, can't think that fast. So I've got to go through my I squared step and then one more down. Negative 20. Okay. Let's go one more over here. This one, as much as I want to just multiply them together first, I got to deal with that negative. So let's take that negative out in form of I, and then we'll multiply everything together. So I've got I root 3 times I root 15. And then when I multiply that together, I get I squared root 45. And you might need to do a little 45 factor tree off to the side. But that will end up getting me 3 root 5. And what does that I squared do to my answer? Makes it negative. Are we okay with that? Did I rush too much through it? Okay. Okay. Next is part number 3. And again, those are all problems kind of like we dealt with. I'm going to do them on the board. I'm not going to talk through them unless you have a question, but I want you to kind of check your understanding. Can you do these multiplications? Can you do these simplifyings? Can you do all that stuff? Okay. See what you remember. And then if you have questions, check in with me because my answers will be up here. That letter A on the board, if you want to check in with your work. Anybody questions on this part? Okay, I'm gonna keep rolling the letter B. If you've already done letter B, it's gonna be kind of long. You can't really simplify it. So if you do it correctly, you might be like, wait, I feel like I should be able to do more. Can't do a lot with this one. Only reason I needed a second step is I wasn't quick enough with my negative 2i squared to just make it 2i, or make it positive 2 from the beginning. Remember radicals, you can't combine unless it's the exact same number. So I wish I could combine those. Can't do it. Once you get B, move on to C. That letter C up on the board. Then when I get to D, you can multiply by a couple things. The exact conjugate of 3i would be negative 3i, so that's what I'm going to multiply by also, so I can show you some simplifying. However, you could just multiply by I on top and bottom for letter D, and that will get rid of the I in the denominator. So you kind of have player's choice there. So I'm just making it a little complicated for no reason, but that's okay. Yeah, Avery.
So I keep forgetting to put the like plus for like the one after you divide it. That
Yes, because it's 1 plus that number or 1 minus 2. Like it's part of it. If it was the denominator, you could for sure get rid of it. If it's like quadratic equation and there's a 1 in front of the radical, you don't need it. But in this specific case, it does matter.
I
That's all I got.
divided by your.
So when I multiplied by negative 3i, that gives me negative 9i squared. And then I squared is negative 1, so negative 9 times negative 1 is a positive.
I multiply by this time.
Great. Okay. Did you get different signs on top? Okay, well then you messed something up. So if we multiply by just I, that should be 3i squared over 2i plus I. And so that's going to be, or I squared, excuse me, that's going to be 2i minus 1 over negative 3.
Yes.
And if you, those are different signs than what I got. You see how my 1 is negative and my 2 is positive? My answer is a positive 1. Your answer is a negative 1.
Oh.
My answer has a negative 2i. Your answer has a positive 2i. So you're fine. You just need to read where the negatives and stuff go. Okay. All right. That's all I got for today.